Now let's see what consistency groups in ONTAP are. First we look at why they may be needed, and then we'll have a demo to see how a basic consistency group can be set up. Now for a long time it's been common practice in ONTAP to create application consistent snapshots as well as crash consistent snapshots, where in the first case the application would be brought into some quiet state just before the snapshot was taken, so that at restore time the application could continue as if nothing had happened, apart from some data loss of course, the amount of which obviously depended on the frequency of the snapshots. And in the case of a crash consistent snapshot, the application should be able to deal with an unexpected and abrupt failure of the system or the application itself. Both methods have been and still are valid options depending on the situation. But what if the application writes to 2 or more volumes or LUNs? And what if the data on those volumes or LUNs is tightly related in the form of a write order or write order fidelity, as it's called, so that the snapshot should be in line with one another and keep the data consistent across the volumes or LUNs? Now this is where consistency groups can do wonders. To be precise, a consistency group is a group of storage objects that can be managed as a single unit. In ONTAP, consistency groups work at the volume level, so the smallest consistency group would be a single volume, because a single volume can hold multiple LUNs which could contain data that needs to be consistent across the LUNs. This may seem strange because a volume is a single entity, but what's relevant is the number of datasets or storage objects that have to be kept consistent. But it's true, in ONTAP you usually create a consistency group of multiple volumes. The way this works is that before a snapshot of, for example, 2 volumes is taken, ONTAP will set up a write fence, which will build an I/O queue, which will be released again only after the snapshot on all the volumes has been taken. So yes, there will be a temporary I/O latency spike, but at least your snapshots will be consistent across volumes. Now there's a lot more to be said about consistency groups, but let's just start with this simple demo. Now in our single node cluster we've got no data SVMs yet, as you can see, so let's create one and we call it NAS. And then we create 2 volumes in the storage virtual machine, and if we don't give them a size they will be 20 megabytes, and for demonstration purposes that's more than enough. We could leave the default snapshot policy, that wouldn't be a problem, but we're going to create a separate snapshot policy for the consistency group in a second, so we decide not to use a snapshot policy at the volume level. So we've got 2 volumes in aggregate1 and the snapshot policy is none. Now we will need a cron schedule for our snapshot policy, but because the smallest default cron schedule is 5 minutes and we are very impatient, we will create a 1-minute schedule first. And then we'll create a snapshot policy that will run every minute and keep 5 snapshots, and it has to be enabled. And when we're done with that, we can create our first consistency group. Now let's call it NAS consistency group, and the volume in it will be volume 1 and the snapshot policy is naspol, the one we just created. And we will add the second volume to the same consistency group. And when we check our work, we see we've got 2 volumes in the NAS consistency group. And within the minute, the first snapshot should arrive. So we wait a couple of seconds and we check again and we see that our first snapshots are there. And we're done.